Today's lesson is going to be on the software design process. We are going to be using a software design process with 6 steps. There's lots and lots of other possible design processes besides what we're going to be using. And all of these different types of methodologies or paths have different paths. But essentially, there's lots of different ways to do it. We're just going to be reviewing the one that we're going to be using. The particular design process we're going to be using mimics the Project Lead the Way's engineering design process. On the right, these 6 steps, starting with defining the problem, are the engineering design process. On the left-hand side is the equivalent design process that we're going to be using in this particular class for writing software. So in engineering class, we would define a problem. Here we're going to be defined. The next step in engineering class was to generate concepts, which is our brainstorming. In this particular class, that's where we're strategizing. The next step in an engineering design process was to develop your solution. Well, for us, that's going to be where we're actually doing our coding. Constructing and testing a prototype, which is where you're building and testing whatever it is that you were trying to design. The equivalent here is we're going to be testing our software. Step 5 of our design process was to evaluate our solution. Again, in this particular class here, the user is going to be testing the software. And then once you're done, you would be presenting your solution to the customer, which again, is just here where we're delivering. Notice that our design process here is a cycle, okay? And very often the cycle could end up repeating itself. Okay, it doesn't always have to go all the way through. It can end up having to kind of cycle back a little bit earlier. And that's in real life. We don't, sometimes when we reach part way through something, we realize, oh, we need to kind of go back and go back to an earlier stage before we can kind of move on. Defining a problem is a very important step. Requirements engineering, in fact, is an entirely separate engineering field in and of itself. If a customer says that these particular 2 input fields are supposed to be the same, well, what does that mean that they're supposed to be the same? The font is supposed to be the same, the color is the same. Is it the same for everybody who's using the program, or is it different for one particular person who has a different background than the others? These terms for requirement engineering are shown here really just so that we can see that defining the problem can be very complicated. The first term, elicitation, is making sure we understand what the problem is from the customer. Specification is where we're describing what the problem is. Validation is we're agreeing with the customer on what exactly the problem is. Negotiation is where we work with the customer so that we know where the problem starts and ends, what the boundaries are. The requirements piece is our contract with the customer, so that we know where we're going to kind of get started, where we're going to end in this particular process. But in our class, we're really not going to sweat a lot of these details because the customer is going to provide very frequent input. So we don't really need to define all of this stuff in the beginning, so don't really worry about these particular terms. Again, we're going to worry about the code. We're not going to be concerned really about all of this defining the problem before we get started. The old style of software development was something called Waterfall Design, and this is a process that went on for back in maybe 1970s, 1980s, and early 1890s. So it's an old way of designing software. In this case, there were managers with dozens of developers that were organized to go ahead and write software. Very rarely did the client, the customer, have opportunity to provide input. Today, what we use the system, what's called agile design. It's agile, meaning it's much more flexible. Okay, it's much more modern. It uses small teams, much less hierarchy, so people are kind of working on their own. And you have very frequent client input. The client is involved all the time. And some examples include what's called Scrum or XP, which is extreme programming development. The waterfall design method, again, this is the old method, okay, had programmers working for 1.5 years. And then first they would be defining, and then you can see it kind of looks like a waterfall. After that, or done with that, it would be strategizing, and then they would step to the code. section, and then they would go to the test section, etc. So each of these steps gets done before the next one begins. Kind of why they call it waterfall, because it has to finish one before they move on to the other. The drawback, though, is that the client doesn't get to see what the software looks like until the entire thing is delivered, and if they don't like it, well, then they're stuck with it. Okay, it requires lots and lots of really good input, specifying what the requirements are initially in the define process. Again, because this is very inefficient in today's world, where we're used to expecting to see apps, okay, and software updates happen very frequently, it's not used today. Today, we use a system much more common is what's called agile development, very similar to in engineering, something called lean manufacturing, where companies can manufacture stuff very quickly in a short period of time. The cycle for agile development is much faster. Instead of 1 or more years, it's 1 to 4 weeks. Okay, if you have a smartphone, okay, you'll notice that you get app updates every few weeks, where they're adding features, they're making changes. For example, this is an example of agile development because they're going through cycles very, very quickly. Okay, so all these steps: define, strategize, code, test, user test, and then deliver. Is entire thing happens in 1 to 4 weeks. It happens over and over and over again, repeatedly. Once you're done, you reflect on the process, see how things go. The point behind agile development is you're not delivering everything at once. You're delivering it one step at a time. Again, when you're getting an app, okay, you're seeing a piece of it working at one point. Then they go ahead and make changes to it. And then they make other changes and they add some additional stuff as well. And the teams kind of organize themselves. There isn't a big boss or lots of managers that kind of run things. Okay, the programmers actually kind of run and organize things themselves. We're going to use a type of agile development that's called a Scrum, and the term Scrum actually comes from the game of rugby. If anybody's ever seen or played a rugby game, it's kind of like the chaos that happens when they first start the game and they throw the ball in. The roles in Scrum development include first the product owner. Okay, the product owner represents the client. The Scrum Master, their job basically is to remove impediments, to stop problems, okay, that get in the way of the team getting things done. And for the most part, the people that are working are team members. They're the ones who develop these software in sprints. Now, sprint implies that it's going to be short and quick, and essentially that's what a sprint is. Sprint is going to be very short and quick. In terms of a workday, a sprint would be an 8-hour workday. For you, your sprint is going to basically be 1 class period, so which is somewhere between 40 and 55 minutes. Again, in Scrum, you're working in self-organized teams. You work on your own. You have very short-term, clear goals, and each member gets to see everybody's progress because, again, you have very frequently are meeting up, and it's very safe to give feedback. You're allowed to go ahead and encouraged to go ahead and provide feedback so that you can get to the end product as quick as possible. Again, we're going to be using Scrum as our framework for our agile development. In industry, a sprint planning meeting would happen at the beginning of the day. And they would be planning out what they're going to do for that particular day. After the planning meeting, then they would go ahead and write code and test it. At the end of the day, then they would have what's called a Scrum stand-up meeting. And it's a stand-up meeting because a stand-up meeting is not going to be long enough to find an office room and sit down, with coffee, etc. It's going to be nice and quick because you're standing. You don't want to be standing around a long time. It becomes real uncomfortable. And basically, this Scrum stand-up and code and test would be an 8-hour cycle. So this whole Scrum code and test and Scrum stand-up would be every single day. Okay, and then once you're done with your 8-hour day, okay, you go ahead and repeat this process. At the end of the week, then you would have a sprint review and a sprint retrospective. That would be kind of like at the end of the week, you're reviewing what you did for the week, look back on what you did, and that would be your 40-hour cycle. That would be your work week. And then you would kind of go back and look and see, well, what do we need to work on next week? And that's what they call your backlog. And then you'd go back and have another sprint planning meeting at the beginning of that, the next work week. In this particular class, the um, the Scrum design process is designed that is on this slide is basically set up for about 10 to 12 class periods, which is really longer than our projects really are. But this is what it would be if we were going to take that long to do a project. So you'd have one session, okay, to go ahead and plan it out. So that'd be one, let's say, class period. And then you'd spend 3 periods, let's say, coding and testing, and then 1 period where you'd go ahead and have your stand-up, okay, and then you'd repeat that same code and test and Scrum stand-up twice, so that would be a total of 3 plus 1 is 4. You're doing it twice is another 4 days, so that'd be an 8 days, and then spend another period where you'd be doing a sprint review, retrospective, all right, and then backlog, and then you'd kind of go back to another sprint planning meeting. Again, our particular project isn't going to, and the Scratch one that you're working on, we're not going to have 10 to 12 days. It's going to happen quite a bit quicker than that. But this is essentially what the slide would look like what the session or the plannings would look like if we were going to do this for 2 to 3 weeks. In real life, teams would focus on something called a burn down chart. Okay, basically the goal is this is how you burn down chart is what you would use to go ahead and make sure you are getting down toward the point where there's 0 work left in the project. You'll notice initially these orange bars represent how much progress is made. In the first few days, really not a whole lot progress is made, okay, because they're just kind of getting started. But later on, as they get closer and closer, their days become much more efficient. There's a lot more to kind of show for themselves. The burn down chart, however, is a little bit beyond the scope of what we're going to be dealing with in this particular class. Right? Again, this Scrum design process, okay, mirrors kind of the design process that we use in our engineering classes.